Welcome everyone. This is Kevin Holbrook from CAD Dimensions, one of your local application engineers out of our Rochester office. Today's topic for our Lunch and Learn is titled Decoding Patterns. I was actually asked by a customer, fairly new customer, to kind of go through all the different pattern options that we have and kind of break down some of the say less often used commands, just so they had an understanding of what's there. If you haven't attended a Lunch and Learn before, what we use these sessions for are basically a web-based, we'll call it training for lack of a better term, but we're going to go ahead and go through in depth all of the pattern tools in SolidWorks. And some of this stuff for you veterans might be a little bit dry. But the nice thing is once you learn what one function does in one, it does repeat itself in all the other pattern commands. I don't think we'll go a full hour today. I'm actually almost certain that we will not. But I want to welcome you to today's Lunch and Learn. Before we get started, a couple of housekeeping issues. If you could post any questions that you do have during anything that I'm presenting in the questions section of the GoToWebinar window, I'll make sure I handle all those questions at the end of the presentation today. Also, if you stick around, we are having a giveaway. We've been doing these on our Lunch and Learns for the last month or so. So I'll be asking a question at the end of today's Lunch and Learn, and you could win a $25 gift card of your choice, plus some swag from CAD Dimensions, and we'll ship that directly to you. So there is benefit to sticking around and listening to some of my dry content as we go. A couple of polls that I have here. I just want to get a quick sense of who has attended Lunch and Learns in the past, just to get an idea of the audience that I'm working with today. See if there's any new attendees. If you could just vote there. All right, I'm going to go ahead and close and show you here. This is actually the very first time I run this poll every time. This is the very first time that I've had no new Lunch and Learn attendees. Next question that I have for you here is really related to topics. Now this topic today is related to something that a customer asked us to show. Now if you have topics that you would like to see covered in a Lunch and Learn, we really, I won't say struggle, but we like to focus it on what you folks want to learn. So if you have a topic, I can already see that there's a few in there that have voted yes or no. Please take a moment here at the beginning and just go to the question section and post your topic in there, and I will make sure either one of our staff contacts you, or we just create the Lunch and Learn. Again, we're doing 3 of these every month, and they can be on other products as well, not just the SolidWorks core. So for those of you 33% that do have topics, feel free to post those as we go across. So decoding patterns is what I called this today, and really what we're going to cover is just patterning in general inside of SolidWorks. And I know that if you've used SolidWorks, you're familiar with patterning, but there's options and tools within all of the patterns that change the way things happen. And I just want to go through as much as I can to get an understanding of what's really going on within each of those. You may not know this, but there are patterns in sketching, patterns for part modeling, patterns in assemblies, and probably one you didn't know is that there's drawing patterns. So the ability to pattern notes in drawings. So like I said, why patterning? I just want to really show the depth of the tools and teach you how to use some of the little nuances of the tools. Let's start out with sketch patterning. Working in the 2D environment, sketching your patterning your physical sketch geometry, And the two options that we have there are our linear and our circular pattern options. Now, they can be found under Tools, Sketch Tools, and you'll notice as I go in here, there's really 4 items listed. 2 of them are for linear and circular pattern, as I mentioned. Then you have 2 options to edit the linear and circular pattern, and notice there is no icon next to the edit. This is simply because there is no physical icon to place on a toolbar to get access to it. You'll also notice that they are grayed out. As with most sketch tools, you must be in a sketch to go ahead and perform the operation. So if I wanted to, let's say in this case, perform a circular pattern, the first thing it's going to ask you for is a center point to perform the pattern around. Now, I'm going to actually do this without physically giving it a center point, because one of the things that this tool does is it automatically selects the origin as the default center point. So I'm just going to skip through all this for a moment and go right down to entities to pattern. Now, I would say this is a little bit of an awkward tool to get used to, because when you want to select something, you're used to having the select icon, the arrow, right? Well, you have a little pencil here, so it almost feels like you're going to draw something, like your line is available, right? So in this case, when you mouse over the geometry, you'll automatically, as soon as you make a selection of a single entity, get a preview. And you'll notice that it's selected my origin as point 1, and it's placed it in the center spot over here, where we initially had our selection set. Now, it also is going to take the closest point from the entity that you've selected, all right, the closest point, and it's going to draw this diametric circle, which we describe with a radius value, from that closest point. And as I start to select more points, you'll see the preview update, but also the circle updates, which gives you the diameter of the pattern. Now let's go through some of the options that we have here, because this is really where the power comes into play. First of all, the angle value that you see is the number of degrees that will participate in the pattern. If your pattern is only 180 degrees, you would put it as 180 degrees. We also will have control, even though we've specified a point, we can actually physically move that point using these 2 options here with the X and the Y. Now I can just use my spin box increments, and as I increment it, you'll notice that it moves the center point by that distance in the X, and it's still going to take and adjust the radius of the arc as well to do that. Also, we can move it in the Y, which essentially performs some sort of angular movement of the pattern as well. Now, if I want to have equal spacing along the way, I can go ahead and select that, which allows me to provide the equal spacing along the angle, or we can physically give the spacing increment and the number of instances. Okay, in this case, we're going to go the full 360. Do I want to control the radius of this circle? When I'm done with this pattern, if I add this dimension radius, it will physically give me a dimension. So now I can control it as part of the sketch. Also, the angular spacing. If I turn this on, you'll notice it turns off equal spacing. I now will get a dimension, so I can control this value, which is our angular spacing. Now, if you're using design tables or configurations, you're going to want to drive this information using the dimensions created. Okay, I'll show you with the dimension radius. Now, also display instance count. Right now, I have it set to 4 instances. Well, I want a dimension that represents the number of instances that I can drive in a design table and drive using other tools within the software. Okay, so these are all options in here. Beyond that, I have the ability to control the radius of the circle. Now this is very analogous to doing what we did up here, which is moving the XY. You'll notice as I increment the radius change, all it's physically doing is moving the center point to make an adjustment on the circle as well. And then right below that is an angular measurement, which again is very similar to moving the X and Y. If I increment the angular value, it's now providing an angle from the original. Okay, so I can make an adjustment from here. At the very bottom of the dialog, and you'll see this on a lot of the pattern tools, is the ability to instances to skip. You will have to activate the box, and what you're looking for are the purplish magenta dots. You click on the dot and it will turn off the instance. If the instance is turned off, it will be listed in orange. Now the instances get numbers based upon their position in the pattern. You can see instance number 3, 1 being the seed, 2 being the second, 3 being the one that I turned off. So circular pattern in sketching has some power to it. If I go ahead and accept this, you'll notice that I now have what is my radius value for my pattern that I can control with a dimension. I also have the instance number that I can control as well. So if I wanted to go to 5, it should equally space out 5 with the one instance number 3 that I turned off. Okay, so sketch patterns for circular sketch patterns. So let's go ahead and look at linear sketch patterns, see if there's any differences in here. The first thing you'll notice when you pop in here for a linear sketch pattern is that you are able to provide directions, and those directions can be using linear edges, sketch lines, axes. You can use a couple different things. Now by default, it's automatically going to grab the axis, in this case the XY axis, to help you with direction. Now you may want to come in here and make a selection to an edge to give your directions a little bit easier, because in this case the X is actually into the screen and I'm looking on the ZY coordinate. Let's go down to entities to pattern. Again, this tool has the same little pencil. It kind of feels like you're going to draw, but in this case you don't have to. The callouts in the screen are editable, like most of SolidWorks tools. So you can go ahead and edit your spacing and instances there. So we'll go ahead and add a few in one direction. Now here's where we have the ability with this linear pattern to start to add some dimensions in there. So I want to add the X spacing, which is this 10 millimeter dimension once it's completed. Do I want to add an instance count? I can go ahead and do that. If I wanted to, with certain selections of direction, I can actually control the angle here as well. For the second direction, I can have the choice of selecting maybe another edge or another location with the same spacing that we would want here as well. Now we're going to go ahead and accept this just so you see all the values that we have here. So now the biggest thing with sketch patterns is really how you get back in and edit and make changes to them. Now it's not like it's a separate feature in the tree, it's like a sketch command, so it's not like you have somewhere to go. Now if I right click on the original seed, you'll notice there's an option in here to edit the linear pattern. This is the same command that you get to here, but you have to have something selected to be able to do that. So if I go ahead and edit the linear pattern, it brings me right back into that same spot, and I can make any adjustments, including my instances to skip here as well. Okay, so very simple, very similar to what we're used to in other commands as far as patterning is concerned. So those are the two patterns we have within sketches. Let's talk a little bit about patterning on the modeling side of things, because there's quite a few. Some you may not have heard of before or may not have ever seen used. From the very simple side of things, we have just our linear and circular patterns that we're used to dealing with here. And then we have sketch-driven patterns, table-driven patterns, curve-driven patterns, which I'm going to show an example of each, fill patterns, and then something I probably most do not know about, and I will say that mine is not working, but I'll give an indication of what it's supposed to do here. I call it cosmetic pattern, and then you can pattern a pattern. So let's just start with linear patterning and go through a little bit of that. So with a linear pattern, it's very simple. A lot of the commands are the same. They can be found on the command manager under our pattern tools, linear pattern. Now, it looks a lot like patterning within a sketch, except first of all, our icon looks a little different. I have my select option there. The cursors just let me know I'm over a face. As far as directions, I can go ahead and select edges for directions. Direction 1, direction 2. With all of the pattern tools within modeling, we're going to have three very important choices. And just to make it clear up front what those three choices are, we can pattern a physical feature or features that have been added to a model. In this case, it's going to be this little slot feature. We would use this features to pattern option. We also have the ability to pattern the physical faces on the model that make up the area I want to pattern. And I will talk about why you would want to use that and where that might come into play for you. If we're dealing with a multi-body environment, whether it's surface bodies or solid bodies, you'll use the bodies to pattern. Now, one thing you want to keep in mind is once you make the choice of what technique you want to use and you accept the command, you cannot come back in and edit the pattern command and change it from features to bodies or faces to bodies. Okay, you make the choice up front. In this case, we're doing features to pattern, and I'm going to go ahead and select the item that I want to use. Now, my spacing in this case is just placed either in the property manager here at the top or in the graphics area. You'll have the direction callouts that you could go ahead and place the items in as well. So it's 20 and 9. All right. So there's my spacing for my pattern, and you can see that I'm overlapping some existing geometry. Let's just start to go to the bottom. I want to just start to point out some of the options that are available in some of the pattern tools, and we'll go through each of these. First of all, full preview, partial preview, really just gives you some graphical look as to where all the features are. And when I started playing with this, in this instance, it's a good way to show as it intersects other features. You can see how the preview goes away. In this case, it was able to give you a preview as it just gets into this boss. As you go partial preview, which is kind of awkward, right? It tells you that it actually shows the preview above the other units, which is almost like they're opposite in this case. So I couldn't really find a rhyme or reason as to what it's able to give you for a preview. But do try toggling those if you don't get the preview that you're looking for. Now the rest of these options I will show in detail as we go through. Let's do maybe some instances to skip on this one. We don't want these ones overlapping. We can go ahead and grab and turn those off. And then maybe we don't want the ones overlapping my bosses in this case. Okay, so it's very easy to make those types of changes with linear pattern. Now there's a couple other things in here that I just want to talk about. Let's just go ahead and accept this so you can see the pattern. You can see how it solved that particular pattern. But why and when would we want to use these options, these first three down here? I'm going to say very sketch for a moment, but let's talk for a minute about geometry pattern. I'm going to show an example of where that comes into play. So let's take a look at a feature like this. When I create this cutout, if we look at the feature itself, the end condition of the feature is an offset from surface. So I use the bottom curved surface as an offset to maintain a 25 millimeters. Now if I perform a linear pattern in this case, using the edge of the model, let's give it some spacing here. If I turn on geometry pattern, what it's trying to do is ensure that the length of all instances of this pattern are the same length. Let me go ahead and accept this so you can see what happened. It physically cut through the entire model because each instance that it created is going to be exactly like the original. It's going to match the geometry. Well, in this particular case, I really want it to maintain this 25 millimeter distance from the bottom edge. So here's a great instance where you would want to turn off geometry pattern. When I accept this, it solves the end condition. It solves the end condition, okay? That adds some time to your pattern because it has to solve each instance. If you got a really huge assembly, that'll add a little time, but look at the difference in geometry. Now, what you want to think about, let's change the original pattern here. Let's make our cut. Let's say this was an offset from surface, and I'm just going to use one of my planes here. Okay, so I have an end condition that the cut is going to solve that's offset from a plane. If I set this without the geometry pattern, it's still going to solve the offset from surface on every single instance. Now, in this particular part, it may not matter because it's not very large. But if you have a very large part and you're creating pattern features, and every instance of the pattern is also solving for its end condition, you're adding time to the solve of that particular feature. So here's an instance where geometry pattern will actually make it faster. Because it's just patterning the physical geometry, the boundary of the hole. It's not worrying about solving the other math associated with it. This will happen much faster. Now you won't be able to see it in this model, but you will see it in larger models where there are end conditions. Okay, so that's where geometry pattern comes into play. Now let's go back into our linear pattern here and just look at what the other options are. Propagate visual properties, this is pretty simple. If you decide to come in here and change the color of the vent feature, let's say we made it red, okay, and I decide to edit the feature and turn on the propagate visual properties, you should get red holes on all the other instances that you have. Very simple. What the kind of gotcha is on that one is when you go to change the color, you got to make sure you change it and apply it to the feature because it's moving the feature colors along with it. It will see if there's an individual face, but if you have a body or some other hierarchical color, it may not move it along for you. Okay. All right. And I crashed. That's beautiful. All right, let's go ahead and relaunch. We don't need to restart you. So just a couple little things there with propagating the visual properties. And you'll see that as we kind of move forward with some of the assembly patterns where you might have colors on the assemblies as well. The next one I want to talk about is the one titled Very Sketch. Okay, now this one's kind of hard to show for linear pattern. It took me a little while to really come up with a scenario where this made the most sense. So if I perform a linear pattern in this case, what I want to happen is as this feature gets patterned along this edge or in this direction, I want the sketch to actually self-adjust itself. So let me explain that a little further. Let me go to the boss. And what I have here is a dimension driving the location of this boss sketch. Now watch as I change this value and make this, let's say, 40. As I change that value, you can see that the length of that feature actually gets longer. And that's simply because it has a tangent relationship at the ends. So it's trying to maintain its tangency to these reference lines. Okay, so when you have an instance like that where you've created a feature that has a dimension controlling its location, and when that dimension's adjusted, the sketch adjusts, you can actually use the linear pattern to adjust the sketch as you're patterning. So let's try this. First thing you'll notice when you go in here is that Very Sketch is locked out. There is only one way to unlock this option within the software, and that is to use a dimension as the direction for the linear pattern. Now, because this dimension is the one we're going to adjust to change the position on the sketch, we're going to go ahead and use that. Let's say we wanted to have, all right, we want our spacing to be 30, and we're going to do 3 of these. Now, one thing you'll notice with this Very Sketch is the preview is going to be worthless. If I pick my feature here, let me pick it out of the graphics, let's see. All right, you'll notice that it does not give me the preview that you would expect. And that's definitely not how many I've asked for. Let's see. Direction 2, okay, we don't want direction 2. All right, direction 1, 30 by 3. All right. So the preview will show that the resulting instances are going to be the same size. But we know that when we adjust in this direction that these are going to get smaller. When I accept it, you can see that it did not happen in this case. Why? I don't know. Oh, because Very Sketch is not on. Very Sketch is what says, okay, it's okay to solve the sketch and essentially making a copy of it as it instances this. Okay, not suitable for geometry pattern. Okay, so let me just explain what happened there. I had geometry pattern on, and this will happen to you. Geometry pattern, I've already said, it says make an exact copy of the original. Now when I go into accept this, it says, wait a minute, you can't have a variant sketch and have a geometry pattern. It just won't work. So if I turn that off in this case, you can see it's created the multiple instances and made an adjustment to the size. Now there's also a variation to this. Now that we're talking about Very Sketch, there's a variation to this that I want to talk about. And let's use Let's use this one here. In the case that I just showed you, we were physically varying the sketch involved in the feature. Now, that was being done because of the relationships in the feature. We weren't physically changing the dimensional value of something within the feature. But let's take the same kind of option here. We'll use a linear pattern. We'll pattern this particular feature. Okay, let's set our spacing, let's say to 5, and we'll have 4 instances. If I go to the bottom of the dialog, there's an option at the very bottom called Instances to Vary. This is closely related to Vary Sketch, except that we're not adjusting the sketch. We're physically adjusting the dimensions and the spacing between the instances. So if I click that on and I scroll down to the bottom here, I'm going to have the ability to change the increments, the spacing increments in each direction that I select. Now, to explain that further, I've set the increment to 5. But if I want the spacing to change by a ½ millimeter as it goes, so notice this will be 5, this will be 5.5, this will be 6. So add a ½ millimeter between them. I can do that. Notice here I also have the ability to choose the feature dimensions I want to vary in direction 1. So I can come in here and say I'm going to vary this and I'm going to vary this. So I can change them and say, okay, the 12 as it patterns, I want you to add or subtract. I want you to subtract 1 millimeter. And these can be negative numbers. So we want to subtract 1 millimeter. So these should get smaller. Now I want to also adjust the radius so that let's add a 1/10 of a millimeter to each of those. Now let me go ahead and accept this just so you see what's happening here. So I've adjusted the spacing, I've also adjusted the length, and also the size of the radius at the end by doing this. Now let's go back into the pattern for a moment, back down to my instances to vary, because I would say you'd use this tool, but you have to have the right geometry to need to use it, with the exception of this next option. So it says left click on an instance modifier to override the dimensions for individual instances. So I can come in here, this is the modifier. If I left click on it, you're familiar with the option we can skip the instance, but we have the ability to modify the instance. So all those parameters that I said could change, I can now make an adjustment. So I want this to be 14 millimeters with a radius on the end of 1.5. Now the result is I've just made an adjustment to that individual item. Instead of it following the rules of our pattern, I can change them individually now, and all those holes are controlled by a single feature. I will also have dimensions for spacing that are controlled on the pattern as well. Controlling also what gets added on the pattern. Remember the ability to increment by 0.1 or 0.5. I can change those as well. Okay, so I have kind of this extra level of control, but the ability to vary those options as well. All right, so hopefully that's kind of something neat that you may not have known about. I want to just jump over to some of the circular pattern stuff. Let's see, let's open these two up. And these you may have seen, they're very similar parts. They're out of the training book. I just wanted to reiterate a couple things here. One is a face pattern. So if I go into a circular pattern, it's very similar to linear, with the exception that we have to pick a pattern axis. Now the pattern axis can be a real axis, a circular edge, a sketch line, a linear edge, a cylindrical face or surface, a revolved face, or an angular dimension. So we have lots of options here. In this case, I'm just going to select the cylindrical surface on the outside. Make sure the dialog is active here. For our features to pattern, I'm not going to use features in this case. I want to physically pattern this rib, but I'm going to use faces to pattern. I'm going to physically select the faces of the model that I want to copy. Now there are some rules to this. Those rules are that the resulting surfaces must lie on the same boundary. So they must be within the same surfaces on both sides. Because the software has to try to patch. It's basically doing some surface modeling in the background where it's copying the surfaces, it's trying to turn it into a solid and keep it that way. Okay. If I accept this, okay, in this case it has an issue, and I'm not sure why, so let's do it again. Let's see. Here, faces the pattern. Should be able to get to each of these, and geometry pattern is fine. Now I'm not sure why this is or isn't going to work, but it will physically patch the model. Now why would you want to use faces to pattern? Well, as you can see, it's a little bit finicky. There's rules. You can even see by the rebuild errors that pop up here that you have to have the right situation to copy faces like this, and the complexity of the faces do affect things. That's the typical issue. Somebody just posted that I forgot a face. Well, that's easy enough. But the explanation doesn't change. I'm physically copying the surfaces and allowing the software to patch. If you have, let's say, a complex blend or area within the software or the model that you want to pattern, and it's made up of multiple features, those multiple features take time to solve, right? So if I were to perform a feature pattern, I might be patterning 4 or 5 features, and each instance might solve for those end conditions, unless I use geometry pattern, of course. But using faces to pattern, again, another way, very similar to geometry pattern, is speeding that up. Now, if we go to the other one, when you have multiple bodies, now you know this when you have the feature tree with multiple bodies listed in the solid bodies folder. That's where the circular pattern, linear pattern method of using body patterns comes into play. So I might do the same thing as pick the outer edge for my area to pattern around. Okay, but now I'm going to use bodies to pattern by selecting the individual body. Let's do a circular pattern, sorry. And we'll do bodies to pattern in this case. Remove some of the options when you do bodies to pattern. There's no geometry pattern, because that's really what it's doing, is copying the physical body around the model. When you accept it, you actually get all the bodies as separate instances, and you'll have to combine them. So again, body pattern is also going to be faster than solving a pattern with end conditions or multiple features. So a lot of times you got to just weigh out which one you want to use versus the other. So moving on real quick here, I want to cover Sketch-driven patterns, these are very simple. All right. Sketch-driven pattern requires you to have a sketch of points. Those points represent where we're going to place the other parts of the pattern. Now you have to be outside the sketch to invoke this, but sketch-driven pattern, it asks for the reference sketch that we've created. Okay, in this case it's the sketch. Notice we have the same options, features, faces, or bodies. In this case I'm going to pattern this sketch, the whole here. And our reference point comes down to which point on the original feature is going to be placed on the point that you've drawn in the sketch. The centroid, or the center of the feature, which will work in some cases, or you may have to have a point that you can select. It may be a center of the sketch for that. You may have to show that and make that selection to make sure you know what's going to be mapped to the others. Notice geometry pattern and visual properties are here as far as propagation, and that command is pretty simple to use. Table-driven patterns. Let's go ahead and look at that for a moment. Table-driven patterns allow you to create a table of XY coordinates that you want to use to create the pattern. Now, for those of you who've been using SolidWorks for a long time, I think this might be the last remaining holdout of the old dialog boxes, like the original. It has all the same options that we have in the Property Manager for all the other patterns, plus a few, but it's in the old format, the old dialog. Obviously, this isn't used very often, or it would be updated. Now, what you do need for a table-driven pattern is a coordinate system. I've just created a coordinate system that says this is my 0, 0, this is my X, this is my Y. At this point, I can go ahead and tell the software, am I copying bodies, features, or faces, same as we had in the other commands. In this case, we'll just use the cut for our features to copy. And then we can start typing in X, Y coordinates. Now, let me just type in a couple here so you can get a sense of what happens. You will get a preview as you type in, and you will see where those other instances are. Now, if you actually have created this table before or created it in Excel, you can actually browse for a text file or a SolidWorks property table file. Not sure you have any of those laying around, but I did create one here. I go ahead and open the property table file. It has all the parameters that I need, and I can accept it. Notice the reference point options that I just showed with sketch-driven are also in here. So this particular command is still stuck about 10 years back. Next one that I want to go through is the curve-driven pattern. Let's use this. So how many of you know how many stitches on a baseball? See if anyone can post this in the question section. And I know you can wiki it, but in this case we have a curve and we need to place the number of stitches on the baseball. And we would use something called a curve-driven pattern. Now this one requires us to provide a curve that represents the pattern direction. Now I'm going to show you the wrong way to start with. I can try to pick the curve directly off the graphics area, but the first thing you'll notice is that the software is trained to pick only that line segment or that edge segment. Well, I want the entire curve. So when you're using curve-driven, you actually either have to create a composite curve and select that entire curve or that sketch from this. Now this curve happens to be a 3D curve. A 3D curve does require some extra inputs. First of all, there's 216 stitches on a baseball, by the way, 108 double stitches, so 216. We have to select our features to pattern, which in this case will be the stitch. But because the curve is in 3D, wow, it's going to crash on me again. Wow. Let's try that again. Because the curve's in 3D, there's actually another input. So if we go back here, the other input is important, especially for these 3D curves. The other input gives it the face that it needs to keep the feature normal to. So if I go 216 in my features to pattern, it's looking for the face normal. Now this only needs to be placed in there if you have a 3D curve. If this curve is on a 2D plane, you do not need to do this. But with a 3D curve, you have to go ahead and provide that. Okay, and this will give you some idea of what you're up against. Now I will explain some of these other options here in just a moment. But notice features, faces, bodies, instances to skip, all the other things that we've described work in the curve-driven pattern piece as well. And the result is your pattern of your baseball. Now I have an example of a curve-driven 2D pattern that I just want to show you because this will maybe make a little bit more sense with those other options. So what I did is I just created a non-symmetric part that's some distance from a curve that's on a sketch. Now I still created a composite curve made out of multiple sketch entities. Now if we do a curve-driven pattern in this case, remember, don't pick it from the graphics, pick it from the feature tree. My features to pattern, we'll go ahead and select that. Okay, make sure I got my direction correct. Now let's do 20 of these things. We won't do as many. Now if I go to a top view, that's where these methods and alignments come into play. Because it's not a 3D curve, I don't need to face normal. But the first thing I'm looking for is the curve method. Notice there's an original offset distance from the original body to the curve. As it goes through, it's going to maintain that offset distance if it's set tangent to curve. Okay. If I have it selected, offset curve. If I set transform curve, it's like drawing that same curve through the center of each of the components, and it's just translated that distance. Okay, so it will be the same curve through the center. In this case, the offset curve is what I want. Now for alignment, tangent to curve, we'll change the tangency to match what the original was. If I select align to seed, this thing will rotate. Okay, it will rotate as you go along. Let's just keep it at tangent. I'm not sure why they're not all showing, but you do have some control over each of the items as far as positioning and curve. And there's really nothing else different within the curve-driven pattern that you would be used to. Fill patterns. Let's go and look at those for a moment. For a fill pattern, that's used for, find my fill pattern here, for filling a particular space within a model with a cutout. If I perform a fill pattern, it's asking me for a boundary, and that has to be a sketch or a surface boundary, a single surface. In this case, we want to stay within the confines of this ellipse. Now, I'm just going to skip down for a moment. Notice the faces to pattern, bodies to pattern, features to pattern. Okay. For features to pattern, I can very easily just select an existing feature. Okay, like this cut extrude. Or if I don't have a cut extrude, I physically have an option here to create the original cut. So I can create the original cut with a circle, a square, a diamond, or I can determine how many sides of a polygon I want. In this case, we're going to take selected features. Now you're going to have control over how the pattern looks, whether I want it to be in a circular array, linear array, or polygon. And I can control the spacing and angle between each of them as well as the direction. So fill pattern allows you to kind of fill in a certain areas, maybe for a vent or air circulation, with a series of holes that you provide, but all the rest of the options are very similar with the exception of controlling your spacing along the way. Now I'm going to add another one to this same model here. This one will not work for some reason in my graphics area, but I want to show you simply because it may be working on yours. I'm on SP3 currently. But in the appearances for SolidWorks, if I expand appearances and go down to miscellaneous, you're going to find a section in there called Real View Only Appearances. Now the reason I bring this up is because there's a tool called a cosmetic pattern. Now if I take this cosmetic pattern and I drag and drop it into the graphics area, this will actually trigger a pattern command. Now if I look back to where we got that, it says Real View Only Appearances. The reason is because these things are only visible when you have Real View on. So I'm going to go ahead and select the surface, and this is what I'm seeing as an issue here. You can select the layout, the angles between them, and the type of pattern you want on that surface. Now I'm just going to jump into the help so you can see what this is supposed to look like. So what this will physically do is create an image that represents the pattern. So if you've been using SolidWorks for a long time, you know that when you create perforated surfaces with hundreds or thousands of holes, it takes a long, long time to rebuild. It's not fast. So using this hole pattern, this cosmetic hole pattern, you can actually, using Real View, see that there are holes there without physically having the holes. Okay, so something you may not be aware is there. And the last one in the modeling section is just I want to remind everyone that you can pattern a pattern as well. Okay, so if you have something like this and you wanted to, it was created using a circular pattern. If I wanted to go ahead and create a linear pattern of a circular pattern, I could go ahead and do that. Okay, so don't be afraid to make that attempt. I can do that over and over again. Now I can create a linear pattern of a circular pattern of a of another pattern. This can continue on that way. All right. Now onto the assembly side. Let's just take a quick look here at what I have. I'm not going to cover each of these because I don't think it makes sense to cover each of those. Linear patterns work the same way. Circular patterns the same way. You're not going to have the very sketch options or any of that. Two that I want to show, the sketch-driven pattern, which is a fairly recent addition to assemblies, and pattern-driven patterns inside assemblies. So let's look at that for a moment. So I want to look at just assemblies here. Let's start with, let's go here. Okay, so in a lot of cases, you have a fastener, let's say, that's going to be patterned to other holes that are existing. And I could most certainly just drag and drop and mate all these in here. Obviously, this wouldn't qualify for a circular pattern. A linear pattern isn't going to do anything here. But the real goal is if I update the feature and the number of holes in that feature, I want to make sure that the number of fasteners also changes. So that's where an assembly pattern comes into play. We're going to call it a pattern-driven component pattern. So the pattern is driven off another pattern. Now the component we're going to pattern is the first selection, and then it's asking for the driving feature or component. The driving feature in this case is one of the other holes that exists. Now you can see this fastener is a little bit large in this case. You can also change what it represents as the seed location, the original hole location, or the original fastener location. Now I'll just show you what this looks like. So if I change this, it's trying to pattern everything in another direction. So it thinks that that seed is the one over here. Okay, we really want it to be this one. All right. Now, instances the skip work here, and you'll have just another option that's very similar to what we've been talking about, propagate visual properties, and this will actually pattern all the fasteners. Again, the nice reason to use this is because if the holes and the hole numbers changes, this will update. A linear and circular pattern, that won't do that. You'll have to change the pattern on the component and then the pattern in the assembly with the fasteners. Okay. Sketch-driven pattern for assemblies. This is something that was added fairly recently. I just have an example of, very similar to what we were doing in a part model. I have points. This is just a 3D sketch, and I have points all over my model. If I want to do a sketch-driven pattern, I go ahead and select that sketch. I select my component I want to pattern. Now, we've been talking about reference point in each of these. This is the point in which it's using to place on the sketch point. Now, in this case, it's using the center of the bounding box, which is going to be in the center of the part. I can use the component origin, or I can physically select a point on the model, and it will copy the model into multiple locations. Okay, so sketch-driven pattern works there as well. All right. Now, to finish up today, I just wanted to talk about two options in drawings that you may not know are there. They're probably not used very often, but I just want to make you aware that they are there. You can actually create patterns of notes inside of a drawing, and I just want to show you that real quick. So if we go ahead and look at our drawing here, we have notes all around the outside of this drawing. I'm just going to delete a few of these. Maybe I'll make this one without a leader. I'll just drop it in here. So let's say I need this note all the way around this particular model. You can get to the command on the annotation toolbar. There's a couple of things to think about when you use these particular tools. First of all, they're not like the other tools where there's a physical feature. Obviously, because we're on a drawing, it doesn't keep track of feature history. So once you create a note pattern, you can't edit the note pattern. It just places the instances of the note. All notes are independent of each other, but it helps you to copy and position notes equally within the drawing. Now if I select, well, just for an example, a circular note pattern, I pick a center point. I can, just like we did with the sketch patterning, I can control the X and Y center, the diameter of the pattern, as well as the instances. Select a note to pattern, and you can see the preview of what you're looking to get. Okay. When I accept it, as I stated, these are all independent. So it doesn't matter, it doesn't lock them down. But what it did do is space everything using the pattern preferences. Okay. So kind of, I guess, the moral of today's session is if you look at patterns, once you really learn the one or two or three extra options and the very sketch options, you can really take that to any level, whether it's part assembly, drawing, and kind of perfect all of these patterning techniques. Okay. Now, for today's giveaway, to close out, the first person to send an email with the correct answer to this next question to marketing@caddimensions.com will get a $25 gift card of your choice to either Tim Hortons, Starbucks, or Dunkin'. We'll ask you which one you want, and you can go ahead and get one of those. And we'll also throw some swag in there for you. So the question today is, we've been blogging here at CAD Dimensions for the last 3-4 months, and yesterday Rachel blogged on our webpage, what is the name of the tool described in Rachel's blog post? If you can send that answer to marketing@caddimensions.com, first one that does it will get the gift card and some swag. Just a little hint there, if you go to caddimensions.com, you can find the blog somewhere on our CAD Dimensions page. So I want to thank everyone for attending. I know for you veterans, this was maybe some review. Hopefully you found one or two new things that you didn't know about before. Thank you for attending. I'll take a second here and just go through some questions. Let's see if we got anything. Nope, it looks like the only question we had related to the content was the fact that I didn't pick all the faces, so looks like we're good. I do have some suggestions in here for Lunch and Learn, so I want to thank everyone for attending. I'll look forward to finding out who got the free gift card, and I will follow up with that person as soon as we find out. Thank you.